Welcome back to Hardware Unboxed. Today we've got another benchmark review of a mobile processor, and this is kind of a weird one. It's Intel's Core i7-11370H, part of their Tiger Lake H35 lineup that was announced back at CES 2021. Tiger Lake H35 bridges the gap, I guess you'd say, between their Tiger Lake UP3 series processors for ultra-portable notebooks and their regular 45-watt H series chips used for production-focused laptops and gaming machines. The 11370H is weird in the sense that it's basically the exact same silicon used for ultra-portable laptops, but overclocked. It uses the exact same 4-core, 8-thread layout, but bumps up the default power limit from 28 watts to 35 watts, increases the base clock from 3 to 3.3 GHz, all relative to the Core i7-11370H. There's also 12 megabytes of L3 cache, an Iris Xe GPU with 96 execution units, and the same memory support as Tiger Lake UP3. And Intel's marketing for this one was quite odd at CES to say the least. Their performance slides focused on single-thread performance gains versus 10th gen, but then when talking multi-thread, Intel decided to compare Tiger Lake H35 to their 11th gen 15-watt processors. Not exactly the same class of system, and it's highly unlikely a bigger gaming system would be tossing up between using the 11370H and the 1185G7. I guess this is partly down to the reality that Tiger Lake H35 and the Core i7-11370H does not pack as many cores as Intel's prior generation Comet Lake H series CPUs, which in the Core i7 range started with 6 cores and also had 8 core options. We'll soon find out how they stack up. And this launch honestly gets more bizarre when you look at the systems out there using the 11370H. Intel's plan for this chip was to create a new ultra-portable gaming laptop segment, which will lead to thin 14 to 15-inch systems suitable for 1080p gaming, harnessing the lower TDP of this chip. It isn't really a new product segment, given Ryzen laptops have been doing this for a little while now in systems like the Zephyrus G14 and Flow X13 from Asus, but it's understandable that Intel wanted a chip for this segment too. However, that's not how OEMs are using the 11370H. The main system on the market today is the Asus TUF Dash F15, the laptop we have in for benchmarking today. It could even be the only system using this CPU. In any case, this is far from the 14-inch laptop with a Z height of less than 18mm that Intel were talking about. This is just your regular 15.6-inch entry-level to mid-range gaming system with a 20mm Z height and weighing in at 2 kilograms. Not a large system by any means, but not the super thin and light system that Intel was talking about. On a surface assessment, this is a perfectly fine system in all honesty, certainly not on the level of the TUF Gaming A15 with Ryzen processors we looked at last year. It has proper ventilation for the cooling fans underneath, a decent 1080p IPS display at up to 240Hz, 16GB of DDR4 3200 in my review unit, and up to an NVIDIA GeForce RTX 3070 running at 80 to 85 watts, which again was what is found in my unit. This is all standard gaming laptop stuff, and I quite like the design Asus are using here at this price point. But confusingly, Asus are choosing to operate the 11370H with a stock long-term power limit of 48 watts, not the 35-watt default TDP that Intel has specified. So not only is the TUF Dash F15 not really that new ultra-portable style gaming system, it doesn't even bother using the chip at 35 watts, which begs the question why Asus chose to use it over Intel's standard 45-watt H series parts like the 10750H or 10870H. I can't really answer that question as it doesn't make sense, but maybe we'll find out in the performance testing. As the chip operates at 48 watts out of the box with a short boost period up to 60 watts, we're comparing it to other 45-watt processors in our charts today, run at a long-term limit of 45 watts. This does give a small power advantage to the 11370H compared to other chips in our charts, however this is the limitation of testing with this platform and laptop. Let's kick off the benchmarks and some productivity tests. In Cinebench R20, the Core i7-11370H performs roughly on par with Intel's Core i7-10750H in the multi-threaded test. This does present a substantial gain to per-core performance, as the 10750H is a 6-core chip versus just 4 for the 11370H, but it still is a relatively weak performer compared to other parts in this chart. Intel's own 8-core processors like the 10870H are a step above in performance, and the 11370H ends up about 20% slower than AMD's last generation Ryzen 5 4600H here. It is faster than Tiger Lake U series processors though, as you'd kind of expect. In the single-threaded test, as expected, we see the 11370H perform significantly better than Comet Lake parts, including the Core i9-10980HK, with about a 25% performance improvement. That's very substantial gen on gen and highlights that what we may see down the line with Tiger Lake H45 chips. The 11370H ends up slightly faster than the 1185 G7 and around on par with AMD's Ryzen 9 5980HS. So when comparing AMD to Intel and current generation processors, it's neck and neck in this workload. In handbrake, the Core i7-11370H is slightly slower than Intel's lowest Core i7 SKU from the previous generation, the Core i7-10750H. While not a huge margin, when comparing these parts at 45 watts and even factoring in the 11370H's slight power advantage in our testing, it's not a great result to see a performance regression. This CPU ends up 17% slower than the Core i7-10870H, which is commonly used in refreshed gaming laptops of early 2021, and ends up 18% behind AMD's Ryzen 5 4600H. Very similar results in Blender, which presents almost identical margins to the handbrake test we were just looking at. As a production system for these heavy CPU limited multi-core workloads, the 11370H fights admirably with just a quad-core design, but ultimately falls short of other Core i7 processors and AMD's entire H series line from last year. Code compilation shows a larger performance delta between the 11370H and 10750H, with the newer Tiger Lake processor ending up 7% behind the last gen Core i7 option. While it is faster than prior Skylake era quad cores operating in this power range, all higher core count parts are better for Chromium compilation based on what we've tested. In MATLAB, the 11370H is able to perform reasonably well, producing performance more in the range of the Core i7-10875H, and slightly ahead of AMD's Ryzen 5 4600H. On the other hand, in our Microsoft Excel workload, the 11370H's performance goes backwards compared to the 10750H and ends up 25% slower than the Ryzen 5 4600H. One of the strongest results for the 11370H is in PC Mark X's applications test, which measures Microsoft Office and Edge web browsing performance. Thanks to high single-thread performance gains compared to Comet Lake, this new Tiger Lake part is able to outperform the Core i7-10870H despite only having half the CPU cores. It's faster than AMD's new Ryzen 5000 35W parts, but not as fast as the Ryzen 9 5900HX. Generally, performance is similar to what Tiger Lake has produced previously in the ultra-portable class. 7-zip compression performance is disappointing and actually isn't quite as fast as our Core i7-1185 G7 laptop. This is because the TUF F15 only boosts up to 60 watts for a brief moment, which is slightly lower than what our 1185 G7 test system achieved. In any case, this is another workload where we see a performance regression, comparing the 11370H to the 10750H, where the 11370H is over 20% slower. In fact, the margin between these Core i7 CPUs is quite similar in decompression as well. 7-zip benefits quite a bit from additional cores and threads, so the 11370H's quad-core design puts it at a disadvantage here despite gains to each core's performance. Acrobat PDF exporting is another strong result for the 11370H, slightly ahead of AMD's new Ryzen 5000 CPUs like the Ryzen 9 5980HS. In Adobe Photoshop, using the Puget Systems workload, the 11370H is able to match Intel's previous generation Core i7 processors. However, once again, boost performance wasn't quite as good as previous Tiger Lake systems I've tested, and on top of that, memory bandwidth may be having some influence as well. The TUF F15 uses DDR4 memory instead of the higher bandwidth LPDDR4X that can benefit Tiger Lake in some of these workloads. In DaVinci Resolve, we start to see the effects of the Core i7-11370H when paired with a powerful discrete GPU. Despite the RTX 3070 generally being one of the fastest 80-watt GPUs you can get, the 11370H appears to be holding it back somewhat in Puget Systems' Resolve benchmark. It ends up no faster than the Core i7-10750H paired with the RTX 2070 Max-Q, and behind 8-core CPUs that use either the RTX 3060 or RTX 3070. It appears the CPU is the limiting factor here rather than the GPU, and ultimately this performance is only modest. In Adobe Premiere, using the Puget Systems export test, the Core i7-11370H delivers disappointing performance. Premiere is more CPU heavy and does benefit from higher core count parts. Most of the H series processors we've tested in this workload are 8-core models, which deliver substantially higher performance. This makes the 11370H a weak option as a Premiere-capable laptop CPU. And finally, we have After Effects here as well. The 11370H configuration with the RTX 3070 at 80 watts ends up around 10% slower than a similar configuration with an Intel Core i7-10870H, which isn't the worst outcome, but a previous generation Core i7 CPU would be the better choice for this workload. Next up, we have some gaming tests. The big point of comparison here is between the Core i7-11370H and the Core i7-10870H using the same RTX 3070 80-watt GPU. Both of these CPUs are being used in this first wave of refreshed RTX 30 series gaming laptops, so we'll get a good look at how they stack up in a moment. I've tested these games at 1080p Ultra settings with NVIDIA Optimus enabled, which is currently the most reasonable CPU limited setup you might use a gaming laptop in. First, I want to start with some GPU limited titles just to warm us up. One of those is Dirt 5. We can see here that with the RTX 3070, the 11370H and 10870H systems perform about the same, which is to be expected. Another title where we see this occur is Metro Exodus. The previous generation system is slightly faster overall, but it's quite similar performance in general. But then when we get into the more CPU limited titles, the situation changes entirely. Here we have Resident Evil 2 using the Balanced preset, which is largely CPU limited on these systems at 1080p. The laptop equipped with the 8-core 10870H is substantially faster. We're talking 54% faster, which is an insane margin for any sort of CPU limited hardware. Luckily though, this is a bit of a worst case scenario for the TUF F15 and the 11370H, so let's move on. In Star Wars Jedi Fallen Order, we still do see a large performance discrepancy between the 10870H and 11370H configurations, but we're only talking a 29% difference here, which is looking a lot better than the previous chart. That's still a large difference, but in a CPU limited game like this, the performance delta isn't that far off what we saw in some productivity benchmarks like Blender or Chromium compilation. When you're packing such a powerful GPU, having that extra CPU headroom does make a big difference. In Borderlands 3, we get a bit of relief. While the 10870H configuration is still faster, it's now just 11% ahead, which is a much more manageable margin and lower than some of the productivity deltas we saw. But it's still slower than quite a popular laptop configuration with the new RTX 3070. We'll show a couple more benchmarks here. One of them is Watch Dogs Legion. Again, we do see a performance discrepancy between the newer quad-core design and the older 8-core design, with the 10870H pulling 16% ahead in this game. Again, everything is tested here with Optimus enabled in an apples to apples comparison. You will gain performance when you disable Optimus and let the display run straight off the discrete GPU, as that will alleviate the CPU bottleneck somewhat. However, older systems gain performance as well with direct DGPU connections, and our goal here is to test in the most CPU limited environment as we can, as we do with all CPU reviews. And the last chart I'll show here is Death Stranding, where again the 11370H system is quite severely CPU bottlenecked. The 10870H configuration was a huge 36% faster, as the quad-core CPU layout is a significant performance limiting factor when playing at 1080p. Given that running at 1080p with Optimus enabled is the default out-of-the-box experience, that's not great. All up, we tested 17 games on the TUF F15 and the performance numbers are not pretty compared to our Core i7-10870H laptop running the same RTX 3070 80-watt GPU. In some games that were extremely GPU limited, the performance delta between the two was small, 5% or less. There was another grouping of results where the newer Tiger Lake design was 10 to 15% slower, and then in the worst cases, we had a couple of results over 35% slower where the games were very CPU limited and basically maxing out the CPU across all 4 cores. At this point, I don't think we need to show any more benchmarks for the Intel Core i7-11370H because we have a pretty good idea of how it performs across both productivity and gaming. I do have a bit to say in this conclusion, so I'll start with the positives. Right now, the Core i7-11370H is the fastest H-series processor from Intel in lightly threaded workloads. It's not an outright win for Intel, but it does improve performance substantially over Intel's 10th gen line. With better IPC and performance per core, the 11370H is also quite a bit faster than prior quad-core designs from Intel in multi-threading. However, that's just about where the positives end for this processor. The major issue for the 11370H is that lightly threaded productivity applications are not really the primary use case for an H series laptop. People buying these sorts of systems, designs like the Asus TUF Dash F15, are either wanting big multi-core and GPU performance for stuff like video editing, 3D rendering, compiling, productivity workloads, or they want a system for gaming, and the 11370H is a big old fail in both of these areas. For multi-threaded productivity workloads, the absolute best thing I can say about the 11370H is that it's as fast as Intel's last generation mainstream Core i7, the Core i7-10750H, depending on the benchmark. But in many cases, it's slower than that part, as Intel are providing 2 fewer CPU cores. This means that when comparing Intel's new baseline Core i7 model to Intel's previous baseline Core i7 model at roughly the same power, we're on average seeing a multi-core performance regression. And that's the most favorable comparison we have in the Core i7 range. Put the i7-11370H up against the 8-core i7-10870H, and the newer 11th gen processor starts losing by upwards of 15%. Put it up against AMD's last generation entry-level Ryzen 5 part, and it loses by even more. There is a clear trend that for these workloads, a sizable IPC gain just can't offset the reduction in CPU core count. As for gaming, well, the Core i7-11370H is quite frankly a rubbish processor for gaming. It causes significant CPU bottlenecks in many titles, which is similar to what we've seen previously with Intel's quad-core parts. It's just that now we have even faster laptop GPUs like the RTX 3070 on hand. At a bare minimum in today's gaming laptops with a high-end part like the 3070, you want a decent 6-core CPU, if not better. The 11370H being a power overclocked U-series part just isn't cutting it here, and I think Intel's attempt at making a low-power CPU into an H-series part for gaming laptops has failed. So my main takeaway here is that the Core i7-11370H is a bad processor and something that you should avoid. If you stick to previous generation Core i7 CPUs, or AMD's Ryzen 4000 lineup or newer, I think in general you'll end up with a superior experience. The risk of severely bottlenecking an RTX 3070 with this inadequate quad-core CPU is far too high for my liking. I also take significant issue with the name Intel has used here. I have no idea how this ended up as a Core i7 part, given you have to go all the way back to Kaby Lake 7th generation parts in early 2017 to find the last quad-core H-series Core i7 CPU, the Core i7-7700HQ as an example. Since then, the Core i7 range has denoted 6-core CPUs, or more recently, 8-core CPUs. Putting the 11370H in the Core i7 series serves to both dilute Intel's Core i7 brand and deceive less tech-savvy customers into thinking they are getting a powerful processor when they aren't. Simply put, the Core i7-11370H should be a Core i3 processor. Instead, Intel are likely to cram 4, 6, and 8-core parts all into the Core i7 range. If and when that happens, what is even the point of having Core i3, Core i5, and Core i7 ranges for laptops? You may as well just forget that branding if it's become totally meaningless for buyers. And if it was a Core i3 part, it would have been more suitable to pair it with things like a GTX 1650 or GTX 1660 class GPU, where it's less likely to run into the CPU bottlenecking issues that we showed with the RTX 3070. This then leaves the Asus TUF Dash F15 as the remaining thing to talk about. It's a bit of a strange one because most aspects to this laptop are perfectly fine. The only glaring issue is the choice of this CPU rather than either a 10th gen Core i7 part or a Ryzen processor. I don't quite understand why Asus chose to use this CPU. It seems most other OEMs passed on this product in favor of last gen CPUs for their early 2021 refreshes, but Asus did not. Did they want to experiment and see what the result was? I'm not sure, but either way, I think unfortunately the 11370H is holding the F15 back from greater things. Anyway, that's it for our look at the Core i7-11370H. We will be following this up with some Tiger Lake H45 coverage not too far away now, I wouldn't expect, so we should have a look at the 6 and 8 core parts, which hopefully should be a bit more competitive with things that are already on the market. If you're interested in supporting the channel and you want to, help us out a little bit, then you can follow our links to the Floatplane and Patreon accounts. Links to that are in the description below. You can also just subscribe to the channel. Thanks for watching, and I'll catch you in the next one.